This video is about angular velocity and voltage relationships. And so in this particular case, we basically have a rod spinning around, and you guys have seen this experiment several times. We started off with it in our trigonometry vector lab. So what we want to do is we want to come up with a relationship between the angular velocity and the voltage. So if the voltage increases, what happens to the angular velocity? Does it continue to increase forever and ever as far as the voltage goes? Or, can we derive this kind of statement or hypothesis from this experiment? That'll be cool to find out. So you can just go into Dropbox here. You'll see a little link, and you'll have these three videos: 1 millivolt, 1.81 millivolts, and 0.61 millivolts. We're going to take the 0.61 millivolts video and the 1.81 millivolt video, determine 2 points to define an equation of a line, and then we want to verify our hypothesis with 1 millivolt, just in case you don't know what we're doing here. Okay, so let's do that. I've already brought these videos down into video physics, so let's process them fairly quickly. So we're going to start off with our 0.61 volt video here. And the first thing that we need to do is to set our origin. So that's your X and Y. We're going to set that at the pivot point. So we have our pivot point here. And then we need to scale our X and Y. So our scale is going to be 0.1 meters. That should be sufficient. Let me pull this in a little bit. That scale is going to be off a little bit. Okay. So from 30 to 40. Let's back that out. Let's go to points. And so we have our crosshairs here. And let's get some points. I am just going to select the first piece of electrical tape here. And before we even begin, I want to show you part of the setup here. You'll notice that I have a power supply down here, and I have a multimeter, and then up on top of that I have a device that allows me to rotate. Basically it's an electrical motor, and I have a pulley system there, and so we're going to cause this rod to rotate around by varying its voltage. That multimeter is set on volts, millivolts as a matter of fact, so that's 0.61 millivolts because it's at its lowest setting. So we can increase it with either one of these knobs here. Okay, so that is pretty much the experiment. Now let's do it. So I'm going to start here, tap. It's totally up to you if you want to use a second piece of tape or the edge of the rod. Just try to maintain your consistency where you measure. I believe that one revolution will be sufficient for this particular experiment. So you can go around multiple times, but one revolution should be sufficient. So I'm just going to double tap here, and I'm going to go ahead and you guys make sure you can save this video, but you don't have to, because I'm just going to look at the Excel spreadsheet. But I would suggest that you upload this video to Dropbox so that I'll have evidence of your experiment when you share that folder with me. But right now I'm just going to save or move this data into a data file, and we're going to open this data file in graphical. So once it's open to graphical, I don't want to do any processing here. The only thing I want to do is to change it into a table and then share it with Microsoft Excel. Let's see, open in Microsoft Excel. Now here's where we're going to do a lot of the processing. Damn it, I gotta do that again. So here are all of our points: time, x, y, x velocity, and our y velocity. Okay, in the next video we're going to process this data, and each data set, in other words, for 1.81 millivolts, when we go to that one, and then what's the other one? 1 millivolts, we're going to do the same thing again and again. So in the next video we will find the value for R and find the value for the velocity here, and we'll talk about a little bit of theory as well, so it can guide us in our experimentation.